Good morning, students. Now we can see approximation algorithm for knapsack problem. First, we are going to see what is knapsack problem. Knapsack problem is defined as follows, that is, having n items with weights w1, w2 up to wn and some set of values v1, v2 up to vn for each item. Then the aim of knapsack problem is to find the most valuable subset of items that fits into the sack. So this is what the definition of knapsack problem. Knapsack problem can be solved or handled using two different algorithms in our approximation technique. First one is a greedy algorithm, another one is an approximation algorithm. Now we are going to see how can we handle or solve knapsack problem using greedy algorithm. Now we can see the procedure for greedy algorithm. First step is we need to compute the value by weight ratio for all the items present or listed in the table. And second cases or the second step is I want to arrange all the items in terms of its value by weight ratio in a non-increasing order, or otherwise I can call it in a descending order. Right? And third step is I want to repeat the following two steps until all the items present in the sorted list has been processed. That is, first I should pick the first item and check whether it fits into the sack. If it fits into the sack, simply I put the item inside the sack. If its weight not fit into the sack, then I should skip the item, that is I should not put the item inside the sack and go for the next item, and again I have to process the same step until all the items has been processed. So this is what the greedy algorithm. Now we can see how this greedy algorithm works. So I have taken an example having 4 items, item 1 up to item 4, and you can see W, that is weight and value for each items. If you take item 1, its weight is 7 and its value is 49. Similarly, for each item they have their own weight and values. So according to our first step, I should calculate the value by weight ratio. So I calculated the value by weight ratio for all the 4 items, and based upon this value by weight ratio, I just arrange all my 4 items in a non-increasing or descending order based upon its value by weight ratio. Right? So as my item 3 has the highest value by weight ratio, it is placed as a first item, and item 1 is the next one having the next lower level of value by weight ratio. In this way I arranged all the 4 items based upon their value by weight ratio in a descending order. Next step is I have to process each item. So here the overall capacity of my sack is 10. And now I am just trying to put the first item, that is item 3. And its weight is 4. Initially my sack has none or no item inside my sack. So the value weight inside my sack is 0. Now I am putting the item 3 having the weight 4. So it satisfies the constraint which is less than my sack weight. So I can put the item 3 inside my sack. Next I am trying to put the item 1 inside my sack whose weight is 7. So while I am trying to put the item 7 inside the sack, already there is an item with weight 4, and if I add the 7 with 4, I am having the total weight of 11, which exceeds the sack capacity. So here it is not possible to place the item 1 inside the sack along with item 3. So I am simply skip the item 3. Next I am choosing the next item, item 4. So now I am trying to add the item 4 into my sack, and its weight is 5. So already inside my sack there is an item 3 with weight 4. So I'm just adding these two weights having the total weight 9, which satisfies my constraint, that is, which is less than my sack capacity 10. So simply I am putting the item 4 inside the sack. At present there are two items inside my sack, item 3 as well as item 4. Next I am trying to put an item 2, which is the last item in my list, and its weight is 3. So already there are two items inside the sack with the total weight 9. Along with that, now I am trying to put the item 2 and its weight is 3. So 9 plus 3, it is 12. And here it exceeds the sack capacity because sack capacity is only 10. So it is not possible to put item inside the sack. So further there is no item present in my list, so I start my processing. Now I am checking what are the items present in my sack. The items present in my sack are item 3 and item 4 with the weight 4 plus 5 9 and has the value of profit 42 plus 30, which is 72. So this is what the optimal solution for the knapsack problem. I can put the item 3 and 4 with total weight 9, which satisfies the constraint because it's less than the capacity of my sack or within the capacity of my sack and has the total weight 72. That's all about greedy algorithm. Now we are moving to approximation algorithm. In approximation algorithm, the scheme is suggested by Professor Shani, and in this method we are using an approximation scheme K, and it is nothing but the subset of less than or equal to K items can be considered, and remaining items satisfying the capacity constraints are added to the list accordingly. And once all the list has been prepared, now I can find an optimal solution from the list. So this is what the procedure of approximation algorithm. Now we can see how it works with an example. See, this is my knapsack problem having 4 items and its weight and value. From this weight and value I am calculating the weight by value by weight ratio, and I arranged my item in a descending order based upon its value by weight ratio, and the total capacity of my sack is 10. Now we can see how this approximation algorithm works. So this is what, as I told you, the approximation scheme here, the K value is 2. So I can take a subset of values starts from 0 item, 1 item up to the maximum of 2 item, not greater than 2. So initially I am taking the subset as 0. It indicates there is nothing inside my sack. So now I am going to see what are the possible items I can add into the sack. So as there is nothing inside my sack, first I am trying to add the item 1. So item 1 weight is 4, so it is less than 10, so I can place item 1. Now I am trying to put the item 2, but the item 2 has the value 7 or weight 7. So if you add the 7 with 4, it exceeds 10, which is 11, so I couldn't put the item 2. So I skip item 2 and try to put item 3, which is 5. So total weight is 4 plus 5, 9. So it is within the capacity of my sack, so I can put item 3. And moving to item 4. Item 4 has the weight 1. So already my sack has 2 items, 1 and 3 with the weight 9. Along with that, if you add 1, you will get 10, which is also within the capacity of sack. So totally I can add or put item 1, item 3, item 4 into the sack. And this is what given in this column. And the third column shows all the values of these 3 items. For example, for item 1 I have the value 42, item 3 30, item 4 4, and that values here I have added and I have put the total weight, total value. Next one is if I put only one item, or if there is only one item inside the sack, that is item 1. If this is the case, what are the items I can add to my sack? So it indicates already item 1 is inside my sack. Along with that, what are the item I can add further? If I try to add item 2, already item 1 is there with the weight 4. So 4 plus 7, it exceeds 10. so I couldn't add item 2. Try to place item 3, so I can put item 3, 4 plus 5, its value is only, its weight is 9. And then I try to add item 4, which is 1, so I can add it because 9 plus 1, it is 10. So in this case, along with item 1, which is already present in the sack, I can add 2 more items, 3 and 4. Now I just add all the values of these 3, or the values of all these 3 items. So 42 plus 30 plus 4, and once again I am getting 76. And next possibility is, instead of just placing only one item inside my sack, which is item number 2. So this is what item number 2. Now item number 2 alone is placed inside my sack. Now my aim is I should find what are the other remaining items I can include into the sack. See, already item 2 is there with the weight 7. Now I try to put an item 1. It is not possible because if you add the weight, it exceeds the sack capacity. So I skips item 1. Try to add item 3. It is also not possible. If I add item 3 inside my sack, 7 plus 5, it exceeds the sack capacity 10. So I skips item 3. And I try to add item 4, which is 1. So 7 plus 1, it is 8. So it is within the sack capacity. So only item 4 alone can add along with item 2. So now I just add the values of these two items, 49 plus 4, which is 53. In this way, I should proceed for item 3 alone. If I placed inside the sack, what are the other items I can add along with the 3? Then I should add all the 3 items value, that is the value, again I will get 76. Similarly, if you go for placing item 4 alone inside the sack and trying to add remaining items along with 4 to fill the sack. So here again I will get the value 76. So one subset having one value has been completed. Now I am going to place two values or subset with two values. So there are possible two values are, two items are 1 and 2, 1 3, 1 4, 2 3, 2 4, 3 4. So these are the 6 possible ways I can group the items. So if I place already 1 and 2 inside the sack, so 1 has the capacity 4, 2 has the weight 7. If you add these two, it exceeds my sack capacity 10. So it is not feasible to place 1 and 2. So from here itself I stop the processing of this algorithm. So it is not feasible. And coming to 1 and 3. So 1 and 3 means it becomes 9. Its weight becomes 9. Along with that I couldn't add item 2. But I can add item 4. So 4 alone can add along with 1 and 3. And I should calculate the total weight of all these 3 items, which is 76. And the same thing is processed for 1 and 4. Item 3 alone can be added with 1 and 4. And if you calculate all its weight or all its value, you will get again 76. Now come again for 2 and 3. If you place the item 2 and 3 alone, then the value is exceeds the capacity, its weight exceeds the capacity of my sack, so it is not feasible. So here itself it stops. And if you put the item 2 4, 2 and 4 is already inside the sack, so its value is, or its weight becomes 7 plus 1, which is 8. It is within the capacity of my sack. But if I try to add item 1 along with that, it is not possible. It exceeds the capacity of my sack. And if I try to add item 3, here again it's not possible because already 8 is inside the sack. If you add 8 with 5, it exceeds the sack capacity. So along with 2 and 4, I couldn't add any other items. I can't add any other items. So simply 2 and 4 alone inside my sack. So for this 2 and 4, I am just adding its value, which is 53. Finally, I am just adding 3 and 4. So for 3 and 4, it is 5 and 6. So along with that, I can add this 1, which will give 10. But I couldn't add 2, which is 7, exceeds the sack capacity. So totally, I will get the value of profit as like this. This is what the second step. Then the third step is, from these I should find the items or subset having the highest value. Among this, the subsets having highest value is, or the highest value of profit is 76, and the subsets include, or the items included here is 1, 3 and 4. So I conclude that optimal solution is 1, 3 and 4. I can plus 1, 3 and 4 into my sack, which with the maximum profit of 76. I hope students you understand the concept. Thank you.